Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA.
So what is Rayman sum? Rayman sum tells you this, that it makes your connection of a series with an integration, like direct connection, not in terms of inequality. We'll see in terms of inequality later on, called integral tests. So what it tells you is that, for example, if I don't know if you remember or not, but summation of f of k by n from 1 to infinity, sorry, k from 1 to n times n, and this limit n tends to infinity. This goes to integration 0 to 1 fx dx. This was done in your school days. Okay. I will revise it once again how it happens. But this was done in your school days. So what's the basic idea, the mathematics behind it? Mathematics behind this is the following, that it's very simple. If you take a function like this, and if you take like this bricks out there, it goes on. Let's say it's a and this is b. So you take n bricks out here, okay? So this is a plus b minus a by n. So the length is a, so you take n bricks. So this is a. This is a plus b minus a by n. Let's call this is a plus twice b minus a by n. And this goes on. This is nothing but a plus n minus 1 b minus a by n. For n, it will be cutting out, it will be b for this part. So take this heights. So if you see this length is, each length is b minus a by n. And the height, let's take this height. So let's call this is, the height is f of a, right? This height is f of a plus b minus a by n. This height is f of a plus twice b minus a by n, and it continues. So what will be this sum? If you observe, this sum will be nothing but summation of f of a plus this height. So this, see, it's 1 into b, so it's k times b minus a by n. So k is here, this is the k part, it's 2 1, then it will be 3, this n minus 1 until it will go to n. Let's go from, so observe, this is the height times b minus a by n. B minus a by n is the length, the width. This is the area. And if you take the sum of it, it will be nothing but the sum of the area of these boxes, these rectangles, these heights, this sum. And k will go from 0 to n minus 1 or 1 to n, like whatever matters. If you take this height and on the right hand side height, this heights, you will see it's 1. It will be the other thing, like it will be 1 to n. You can also do it from k to n minus 1. So this is the height, this is the width, and it's sum of it. So, and if you take limit n tends to infinity, n means what? N was the number of subdivisions. That means this will become smaller and smaller. As you can understand, as you take n tends to infinity, limit, this will turn out to be the area under the curve. And this will go to integration. The area goes from a to b, and the function is fx dx. This is the fx dx, fx, right? So this height is f of a plus b minus a by n. Each one of them. F of k times b plus a minus n for the kth interval. So height of kth interval and height or width of kth interval, but it is same for all of them. So it's nothing but the area under the, this is nothing but the area with n rectangles. When you increase n tends to infinity, you will get infinity rectangles, which will be equivalent to the area under the curve. And therefore we get the result that limit n tends to infinity b by a times n, this is the width, summation of k from 0 to n minus 1. It can be from 1 to n, the same thing. From 1 to n, it will be this. You take this height, the right hand side height. It will be this for a 1 to n. This will be for 1 to n. Get the blue hands, blue side, blue thing. F of a plus k times b minus a by n. This will go to, limit of this is nothing but integration 0 to, sorry, a to b fx dx. This is very important result, because you can directly, so you can see that, sorry, you can see how integration is related to series. You will see how integration is seriously related to series in this way. So it's the series here, right? The series here is sum f times constant by n. So it converges to this. All of you understood this, yes or no? The basic theory. If you have some doubt, tell me. All of you got it, yes or no? Do you understand the geometry of it? If no, please tell me. I'll explain it to you once again. All of you understood this?
So please explain it once again.
Which part? Tell me.
So the geometry, how we are counting these blocks. I'm confused in that. I mean,
Tell me which part. Like there are a lot of parts, right?
sir, where you have drawn the rectangles.
So let's say, so we take this A, and then we mark this intervals, n intervals. So let's take this B. So n intervals is this this x point on x-axis will be, as you can see, the kth point will be a plus k into b minus a by n, because each length is b minus a by n. A b length is divided into n intervals, so each length will be b minus a by n. So the kth interval will be, the kth length will be a plus k into b minus a by n. Did you understand? This will be a plus, for this k it will be k is equal to 1. For this it was k is equal to 0. For this it is k is equal to n. For this k is equal to n 2. It goes on. Did you understand?
Okay,
Sorted
sir.
this part. All of
Yes,
you
sir.
understood this. Now you can take two things. So you want to approximate this area under the curve. You can do it in two different ways. You can take this height and make a box. So this height is nothing but, here you're taking f of a, and take the next height. This next height is this height. This length is what? This length is f of, at a, this f of a, right? This length. Then at this point, it's again, you can understand it's, so at kth. So this height is f of a. This height will be f of a plus k times, like 1 times b minus a by n. The next height will be that. So similar to the last one, so this height will be, next height will be f of a plus twice into b minus a by n, and the next height again will be f of a plus thrice into b minus a by n. It will go on. So this is the height of the k plus 1th rectangle. Now the area of the rectangle is nothing but the height into width. The width is b by n for all of them, right? B by a by b minus a by n, the length.
I got it, sir, now.
So therefore this is the area. This is terms of area, and we have to take summing it up, and n tends to infinity. So as n tends to infinity, this becomes finer and finer rectangles, and it will go to the area. Okay, that's the basic idea. All of you understood right now? Yes or no? Great. So let's do some examples. So simple. Let's say I'll do one example. Limit n tends to infinity. Summation of I from 1 to n. 96i plus 20n by 8in plus n squared. So let's do this. It's easy. You can see. You have to tell first take. Let me see. It will be probably 1 by n. Here observe that for a is equal to 0 and b is equal to 1. This is the whole thing. So let's do this. This one will be, understand, limit n tends to infinity. You take 1 by n common, you can see. Take 1 by n common, you will see. So let's do this. So 1 by n common, okay, let's write like this. This term, 96i plus 20n plus 8in plus n squared, written as 96i by n plus 20 plus 8i by n. For to write this, we need to express in forms of I by n, because the summation is k by n, like write that, right? Plus, so therefore you have to divide by n squared. So it's n squared times this, and it's n times this. And you can understand that this n by n squared will turn out to be 1 by n. You can see, therefore you can write it as limit n tends to infinity, 1 by n summation of I from 1 to n, 96i by n plus 20 by 8i by n plus 1. So you can see this is nothing but f of y by n, where fx is equal to 96x plus 20 by 8x plus 1. So therefore this limit doesn't go anywhere but this fx dx, where fx is this. And now all of you can find this using whatever ways you know. It will be something in terms of log, but you understood this. All of you understood this? Yes or no? This example? Okay. So another interesting result that I will tell you, and I will do another, I will take an extra class for this, guys, for a revision 1 hour class or 45 minutes class in the weekend, probably, to do an extra revision of series and problem solving. That, oh yeah, someone will take it to tell you about. Okay, I will do one more example. Just give me. You can do another example like this. That, yeah, limit n tends to infinity. This is not a partial sum. This is a product. You can convert product by logarithm to turn it into a series. So now you will see this kind of thing, like you will see this 1 by k kind of thing, like 1 by n, 2 by n, 3 by n. This comes up in, actually, you will probably find it's equivalent to a Riemann sum. Okay, when you will see this kind of thing coming up, the 1 by n, 2 by n, 3 by n, all of them coming up in a single place under a single summation. So what I do, it's same as e to the power limit n tends to infinity. So what I will do is that I will, let's say this is ln. So limit n tends to infinity, ln is nothing but e to the power limit n tends to infinity log of ln. It's continuous. Okay, like ln is equal to e to the power log of ln, a is equal to e to the power log of x, x is equal to e to the power ln x. So we're using this thing here by continuity of e to the power x. Okay, or let's call this Pn, because this ln and this ln is confusing, log of Pn. And this implies that e to the power limit n tends to infinity. Log this will nothing but 2 by n square will come up. This will become a sum k from 1 to n 1 plus k by k square by n square. Okay, there is another part too. There's an n multiplied here, k multiplied here, I guess. Yes, k multiplied here. If you take a log of it, it will be k times 1 plus k square by n square, right? K will come down. So therefore, it's e to the power limit n tends to infinity 2 by n square summation k from 1 to n. Now you need n, so observe that there's an extra k out here. So it's k by n times 1 plus k square by n square. So you can see it's nothing but e to the power limit n tends to infinity twice limit 1 by n summation of k from 1 to n f of k by n. You can see that f of x is nothing but wherever there is k by n replaced by x is equal to x times 1 plus x square. Therefore, this goes to nothing where but 2 to the power integration 0 to 1 fx dx. All of you understood this? Yes or no? Great. So, okay, I couldn't do comparison tests, but Raymond sum is done. Thank you. What you need to do is the following that. So I will take an extra class on this, on comparison test and Vigo notation. This is very important. That will 45 minutes class in the next weekend. Okay, I will talk to you about this later on. So I hope you got a good introduction to sequences. Next day there will be more comparison tests and other things coming out, and you will enjoy it, of course.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.